Welcome, weary traveler, to a journey not through the cosmos, nor the quantum realm, but into a universe far more intimate, yet equally profound, the universe within us. Tonight, we turn our gaze inward to a phenomenon as ancient as humanity itself, a silent language spoken across cultures and centuries, a release as universal as the breath we take. We speak, of course, of tears, not merely drops of salty water, but complex biological marvels, each one a tiny, shimmering world carrying secrets of our deepest emotions, our very biology, and the intricate dance of our shared human experience. For centuries, tears have been shrouded in mystery, dismissed as mere physiological responses, or perhaps as simple expressions of sorrow. But what if I told you that within each tear lies a symphony of molecules, a chemical signature unique to its origin, a silent messenger carrying information far beyond what the naked eye can perceive? What if these tiny droplets hold the key to understanding not just our pain, but our joy, our empathy, and even our very survival? Tonight, we will embark on a tranquil exploration of the chemistry of tears. We will delve into the hidden depths of their composition, unraveling the molecular tapestry that differentiates a tear of irritation from a tear of profound grief. We will journey through the intricate biological pathways that bring them forth and ponder the profound psychological and social roles they play in our lives. So, dim the lights, find a comfortable space, and allow your mind to drift into the gentle current of scientific discovery. As we uncover the salty release of emotion, one tear at a time, the three faces of tears, a chemical portrait, eyes. These remarkable windows to the soul are constantly bathed in a delicate film of liquid, a testament to the body's ceaseless dedication to protection and maintenance. This ever-present moisture is not a single, undifferentiated substance. Guardians, the unsung heroes of ocular health, basal tears. Basal tears, the silent guardians. Basal tears are the quiet, continuous flow that keeps our eyes lubricated, nourished, and protected from the microscopic debris that constantly assails them. Imagine a pristine, invisible river, constantly cleansing and renewing the delicate surface of your eye. These tears are the foundation of ocular comfort, providing a smooth, clear surface for light to enter, allowing us to perceive the world with clarity. They are the unsung heroes of our daily vision, working tirelessly, often unnoticed, to maintain the delicate ecosystem of our eyes. Think of it as a meticulously balanced solution, each component playing a vital role. The water, of course, provides the necessary hydration, while electrolytes like sodium, potassium, and chloride maintain the osmotic balance, ensuring the tears don't draw too much or too little water from the eye's cells. The structure of basal tears is not merely a homogeneous liquid, a sophisticated, multi-layered marvel. The innermost layer, the mucin layer, acts as a sticky anchor. Without it, our tears would simply bead up and roll off, leaving our eyes exposed and vulnerable. Above this lies the thickest layer, the aqueous layer, a veritable ocean of water, dissolved salts, and crucial proteins. And finally, an outer lipid layer, a thin film of oil, acts as a protective shield. Within this aqueous layer, a remarkable array of proteins performs a multitude of functions. We find lactoferrin, a powerful antimicrobial agent that binds to iron, depriving bacteria of a vital nutrient and inhibiting their growth. Then there's lysozyme, an enzyme that acts like a tiny molecular scissor, breaking down bacterial cell walls, offering another layer of defense against infection. And tear-specific prealbumin, a protein whose exact function is still being fully elucidated, but is believed to play a role in maintaining the stability of the tear film itself, ready to neutralize threats and maintain a sterile environment. Their presence underscores the fact that basal tears are far more than just a lubricant. They are an active, dynamic defense system, working tirelessly to protect our precious sense of sight. Reflex tears, the body's emergency flush knout. Imagine a sudden intrusion, a speck of dust, a stray eyelash, the pungent fumes of a freshly cut onion, or the stinging sensation of smoke. In these moments of acute irritation, our eyes deploy a different kind of tear, a rapid, forceful response designed to expel the unwelcome intruder. Reflex tears. These are the body's emergency flush, a powerful torrent designed to wash away irritants and restore clarity. Reflex tears are produced in significantly larger quantities than basal tears, a veritable flood designed for rapid cleansing. While they share many of the fundamental components of basal tears, water. The lacrimal glands, sensing the irritation, spring into action, releasing a copious flow of liquid to literally wash away the offending substance. This increased volume is crucial for effectively diluting and removing irritants from the delicate surface of the eye. Can also show variations in the concentration of certain protective elements. For instance, while proteins like lactoferrin and lysozyme are present in both, their concentrations might be adjusted to enhance the immediate defensive response. The goal here is not subtle maintenance, but rather an immediate, robust expulsion. Think of it as the difference between a gentle stream and a powerful hose. Both deliver water, but with vastly different intensities and purposes. Reflex tears are a testament to the body's remarkable ability to protect itself from external threats, a rapid and effective defense mechanism that safeguards one of our most vital senses. Emotional tears, the salty release of the soul. And then there are the tears that speak a language beyond words, the tears that well up from the deepest reservoirs of our being, born not of physical irritation, but of the intricate tapestry of human emotion. These are emotional tears, a unique and profoundly human phenomenon, a salty release that accompanies moments of profound sadness, overwhelming joy, deep empathy, or even intense frustration. Unlike their basal and reflex counterparts, emotional tears carry a distinct chemical signature, a silent message whispered from our inner world. What makes emotional tears so different? Beyond the basic components of water and electrolytes, emotional tears contain higher concentrations of certain biological molecules, acting as subtle chemical messengers. One such molecule is prolactin, a hormone often associated with stress and lactation. Its presence in emotional tears hints at a deeper physiological connection between our emotional state and our bodily responses. We also find elevated levels of adrenocorticatric hormone, or ACTH, a key player in the body's stress response system. Its release during emotional crying suggests a mechanism for shedding excess stress hormones, a kind of physiological detoxification. But perhaps one of the most fascinating components found in emotional tears is leukenkephalin, a natural opioid peptide. Think of it as the body's own internal painkiller, a molecule that can bind to opioid receptors in the brain, potentially contributing to the sense of relief and calm that often follows a good cry. This suggests that emotional crying is not merely a passive expression of distress, but an active, self-soothing mechanism, a biological balm for the soul. The presence of these neurochemical compounds in emotional tears is a profound revelation. The elevated levels of potassium and manganese in emotional tears further contribute to their unique chemical profile. Emotional release. It's as if the body is actively shedding not just water, but also the chemical byproducts of intense emotional processing, a physical manifestation of emotional cleansing. The distinct chemical composition of emotional tears has led scientists to hypothesize that they may carry subtle chemical signals influencing not only the crier, but also those around them. This concept, often referred to as chemosignaling, suggests that the unique molecular cocktail in emotional tears might unconsciously communicate emotional states, potentially fostering empathy and social bonding. Imagine a silent, invisible language spoken through the very essence of our tears, connecting us on a primal, biological level. This fascinating area of research continues to explore how these chemical signals might impact our social interactions, our capacity for compassion, and our collective human experience. The biological symphony of crying, from brain to tear duct, the act of crying, whether in response to a physical irritant or a profound emotion, is not a simple reflex, but a meticulously orchestrated biological symphony involving a complex interplay between our nervous system, our endocrine system, and the intricate machinery of our lacrimal apparatus. It is a testament to the body's remarkable ability to respond to both external stimuli and internal emotional landscapes. The brain's role, orchestrating the flow at the heart of this biological symphony, lies the brain, the ultimate conductor of our bodily responses. When it comes to emotional crying, the limbic system plays a starring role. This ancient part of our brain, often referred to as the emotional brain, is a network of structures involved in emotion, motivation, memory, and arousal. Key players within the limbic system, such as the amygdala, responsible for processing emotions, particularly fear and pleasure, and the hypothalamus, which regulates many bodily functions. When we experience a strong emotion, signals are sent from these limbic structures to the hypothalamus. Our conscious control is divided into two branches: the sympathetic nervous system, our fight or flight response, and the parasympathetic nervous system, our rest and digest response. While both can be involved, the parasympathetic nervous system, particularly its cholinergic pathways, is primarily responsible for stimulating tear production. Specifically, the lacrimal glands, responsible for producing tears, receive signals via nerves originating from the brainstem, which are influenced by the limbic system. Acetylcholine, a neurotransmitter, plays a crucial role in stimulating the release of water. Neural pathway ensures that our emotional state can directly translate into a physical manifestation, the shedding of tears. It's a remarkable example of the profound connection between our mind and our body, where thoughts and feelings can literally bring forth a physical cascade. The endocrine connection, hormones in harmony beyond the immediate neural pathways. The endocrine system, our body's network of hormone-producing glands, also plays a significant role in the crying response, particularly in emotional tears. As we discussed earlier, the presence of hormones like prolactin and ACTH in emotional tears is a clear indicator of this connection. When we experience stress or intense emotions, the hypothalamus signals the pituitary gland, often called the master gland, to release these hormones into the bloodstream. Prolactin, while primarily known for its role in milk production, is also released during stress and emotional arousal. Its presence in tears suggests a broader function in the body's stress response and recovery. Similarly, ACTH, released from the pituitary gland, stimulates the adrenal glands to produce cortisol, the primary stress hormone. The shedding of tears containing these hormones may be a way for the body to rid itself of excess stress chemicals, contributing to the feeling of relief often experienced after crying. This hormonal interplay highlights crying as a complex physiological process, not just a simple emotional outburst, but a sophisticated mechanism for maintaining internal balance. The physical manifestation, from gland to glimmer, the journey of a tear begins in the lacrimal glands, almond-shaped structures located above the outer corner of each eye. These glands are constantly producing basal tears, maintaining the eye's lubrication. However, when stimulated by irritants or emotional signals from the brain, they can dramatically increase their output, producing the torrent of reflex or emotional tears. Once produced, tears flow across the surface of the eye, collecting in the inner corner near the nose. From there, they drain into tiny openings called puncta, into the lacrimal sac. Finally, the tears travel down the nasolacrimal duct into the nasal cavity, which is why a good cry often leads to a runny nose. This efficient drainage system ensures that excess tears are removed from the eye, preventing overflow. Though during intense crying, the system can be overwhelmed, leading to tears spilling down the cheeks. The physical act of crying also involves the coordinated contraction of facial muscles, particularly around the eyes and mouth. These muscle movements, along with changes in breathing patterns, are part of the visible and audible cues associated with crying. The trembling chin, the quivering lips, the constricted throat. These are all components of the body's holistic response to emotional intensity, a physical manifestation of an internal storm or release. This intricate biological dance, from the subtle signals in the brain to the visible flow of tears, underscores the profound complexity and adaptive significance of crying in the human experience. The psychology of crying, a spectrum of emotions. The intricate biology. Crying is a deeply psychological phenomenon, a universal human expression that transcends cultural boundaries and speaks to the very core of our emotional landscape. It is not simply a response to sadness, but a multifaceted reaction to a wide spectrum of human experience. A release valve for the soul, and a powerful tool for connection. Why we cry. Unpacking the triggers. The triggers for crying are as diverse as human emotions themselves. While often associated with sorrow and grief, tears can flow from moments of overwhelming joy, profound relief, intense frustration, or even deep empathy. Consider the tears shed at a wedding, a reunion with a long-lost loved one, or the triumphant conclusion of a challenging endeavor. These are tears of happiness, a testament to the fact that our emotional capacity extends far beyond the confines of sadness. Crying can also be a response to feelings of helplessness or powerlessness, a visceral reaction when confronted with situations beyond our control. It can be a release from accumulated stress, a physical manifestation of the body's attempt to shed the burden of emotional tension. The tears that fall in these moments are not necessarily a sign of weakness, but rather a powerful indicator of our capacity to feel deeply, to be moved, and to respond authentically to the complexities of life. Furthermore, crying can be a response to witnessing the suffering of others, a profound expression of empathy. When we see someone in pain, our mirror neurons fire, allowing us to vicariously experience their emotions, and sometimes our own tears become a silent acknowledgement of their struggle, a shared moment of humanity. This empathetic crying underscores the deep interconnectedness of our emotional lives and our innate capacity for compassion. Crying as emotional regulation, the cathartic release, one of the most significant. Many people report feeling a sense of relief, a cathartic release after a good cry. This post-crying calm is not merely anecdotal. It is supported by scientific observations. The act of crying can activate the parasympathetic nervous system, promoting a rest and digest state, which helps to calm the body and mind after a period of emotional arousal. The release of endorphins, our body's natural painkillers, during emotional crying also contributes to this feeling of well-being. These endogenous opioids can reduce pain and promote a sense of calm, acting as a biological self-soothing mechanism. It's as if the body has its own built-in emotional reset button, a way to process and alleviate intense feelings, allowing us to return to a more balanced state. This physiological and psychological interplay highlights crying as an active coping strategy, a natural way for our bodies to manage emotional overload. Moreover, crying can provide a temporary distraction from overwhelming thoughts, allowing for a shift in focus and a moment of emotional processing. It can be a signal to ourselves that we need to slow down, acknowledge our feelings, and perhaps seek comfort or support. In this way, crying acts as a vital component of our emotional toolkit, helping us navigate the turbulent waters of our inner lives and emerge with a renewed sense of clarity and calm. Asterisk. Crying and social bonding, a silent language of connection beyond its individual benefits. Crying serves a profound social function, acting as a powerful nonverbal language that fosters connection, elicits support, and strengthens the bonds between us. From the earliest cries of an infant signaling a need for care, to the shared tears of joy or sorrow among friends and family. Crying is a fundamental aspect of human social interaction. When we cry, we signal vulnerability. This vulnerability, far from being a weakness, can be a powerful catalyst for empathy in others. Witnessing someone's tears often triggers a compassionate response, a desire to offer comfort, understanding, and support. This innate human reaction to tears is a cornerstone of our social fabric, fostering altruism and collective well-being. It's a testament to our capacity for compassion and our willingness to reach out to those in need. The chemical signals in emotional tears, as we discussed earlier, may also play a subtle role in this social dynamic. While still an area of active research, The idea that tears can carry unconscious chemical messages that influence the emotional state or behavior of observers is a fascinating one. It suggests a deeper, almost primal form of communication, where our tears can speak volumes without uttering a single word, fostering a sense of shared humanity and mutual understanding. In a world that often encourages stoicism and emotional suppression, the act of crying stands as a powerful reminder of our shared humanity, our capacity for deep feeling, and our innate need for connection. It is a testament to the fact that vulnerability can be a source of strength, and that, in our moments of deepest emotional release, we often find our greatest connections to one another. Crying, in its essence, is a bridge between souls, a silent affirmation of our shared journey through the vast and wondrous landscape of human emotion, the unseen world, microscopic beauty of tears. As we conclude our journey into the chemistry of tears, let us take one final, lingering look at their unseen beauty. When a tear dries, the dissolved salts, proteins, and other molecules within it crystallize, forming intricate, often breathtaking patterns. These microscopic landscapes, unique to each tear and its origin, are a testament to the hidden complexity and artistry within us. Each crystalline structure tells a silent story, a unique fingerprint of the moment it was shed. The precise arrangement of salts and proteins, influenced by the tear's chemical composition, creates these delicate, fractal-like designs. It is a visual echo of the emotional and physiological state of the crier, a fleeting masterpiece born of human experience. These patterns, invisible to the naked eye, remind us that even in our most vulnerable moments, there is profound beauty. An intricate order is an emerging field that holds immense promise. By analyzing these unique signatures, scientists hope to gain deeper insights into various eye conditions and perhaps even develop new diagnostic tools. But beyond the scientific applications, there is a profound aesthetic appeal to these hidden worlds. A reminder that even the smallest, most ephemeral aspects of our being hold a universe of wonder. Conclusion: the enduring mystery of emotion have journeyed through the intricate chemistry, the biological symphony, and the profound psychology of tears. We have seen how these seemingly simple droplets are, in fact, complex chemical messengers, vital biological responses, and powerful tools for emotional regulation and social connection. From the silent, protective basal tears to the cleansing torrent of reflex tears and the emotionally charged release of emotional tears, each type plays a crucial role in our well-being. Yet, despite our scientific explorations, the true essence of tears, why does this particular physiological response accompany such a wide range of emotions? The answers, perhaps, lie not just in the molecules and neural pathways, but in the very fabric of what it means to be human, to feel, to connect, to heal, and to express the inexpressible. So, the next time tears well up in your eyes, whether from joy or sorrow, remember the intricate dance of chemistry and biology unfolding within. Remember the silent language they speak, the profound connections they forge, and the ancient wisdom they carry. Allow them to flow, for in their salty release lies a profound affirmation of our shared humanity, a testament to the enduring power of emotion, and a gentle reminder that even in our vulnerability, we are connected to something vast, beautiful, and eternally mysterious, the silent language of the soul. why tears matter before we delve deeper into the intricate chemical and biological underpinnings of tears. Let us pause to consider their profound significance in the human experience. Why do we cry? This seemingly simple question unlocks a cascade of complex answers, touching upon our evolutionary history, our deepest psychological needs, and the very fabric of our social connections. Tears are more than just a physiological response. They are a silent language, a universal idiom of our inner world, understood across cultures and generations. From the moment of birth, a baby's first cry signals distress, a primal call for care and attention. Crying expands, encompassing the full spectrum of human emotion. We cry not only in moments of profound sorrow, but also in the throes of overwhelming joy, in the face of injustice, in moments of deep empathy, and even in the quiet contemplation of beauty. Consider the tears shed at a wedding, a graduation, or the birth of a child. These are tears of happiness, overflowing from a heart brimming with love, pride, and gratitude. They are a testament to the intensity of positive emotions, a physical manifestation of a soul deeply moved. These tears, chemically distinct from those of sadness, underscore the multifaceted nature of our emotional landscape, reminding us that crying is not solely a marker of distress. The tears of grief, loss, and heartbreak are a visceral expression of pain, a release that can feel both agonizing and, paradoxically, relieving. In moments of profound sorrow, when words fail to capture the depth of our suffering, tears become our eloquent advocates, communicating a vulnerability that invites compassion and support from others. They are a testament to our capacity for attachment, for love, and for the profound impact that loss can have on the human spirit beyond the personal catharsis. Tears play a crucial role in our social interactions. They are a powerful signal, communicating our emotional state to those around us, often eliciting empathy, comfort, and a desire to help. This innate human response to tears fosters social bonding, strengthening the ties that bind us together. As communities and as a species, the act of crying stands as a powerful reminder of our shared humanity, our capacity for deep feeling, and our innate need for connection. It is a testament to the fact that vulnerability can be a source of strength, and that in our moments of deepest emotional release, we often find our greatest connections to one another. As we delve into the scientific intricacies of tears, keep in mind this broader context of their human significance. For every chemical compound we identify, every biological pathway we trace, there lies a deeper story of human experience, a silent narrative etched in the very essence of these salty drops. They are a bridge between our inner world and the outer, a testament to the profound interconnectedness of our minds, bodies, and social lives. Basal tears, the unseen architects of ocular health. Let us return to the foundational layer of our tearful existence. Basal tears, these are the unsung heroes, the constant, silent architects of our ocular health. Imagine a microscopic, self-renewing ecosystem meticulously maintained on the surface of your eye, a delicate balance crucial for clear vision and comfort. Basal tears are not merely passive lubricants. They are an active, dynamic system, constantly working to protect, nourish, and cleanse. Their continuous production, approximately 0.5 to 2 microliters per minute, ensures a constant flow that washes away microscopic dust particles, environmental pollutants, and cellular debris that inevitably accumulate on the eye's surface. This constant flushing action is a primary defense mechanism, preventing irritation and potential infection. Think of it as a miniature self-cleaning window, perpetually maintained for optimal clarity. Beyond their cleansing role, basal tears are vital for the health of the cornea, the transparent outer layer of the eye. The cornea, unlike most other tissues in the body, does not have its own blood supply. Instead, it relies entirely on the tear film for its oxygen and nutrient supply. Basal tears deliver essential electrolytes like sodium, potassium, and chloride, crucial for maintaining cellular function and osmotic balance. They also provide glucose, the primary energy source for corneal cells, ensuring their metabolic needs are met. Without this constant supply of nutrients, the delicate corneal cells would quickly become compromised, leading to impaired vision and discomfort. The intricate composition of basal tears extends to a diverse array of proteins, each with specialized functions. We previously mentioned lactoferrin and lysozyme, the formidable antimicrobial agents. Lactoferrin, a protein that binds to iron, effectively starves bacteria of a crucial element necessary for their growth and proliferation. Lysozyme, on the other hand, acts as a potent enzyme, directly attacking and breaking down the cell walls of various bacteria, providing a direct line of defense against microbial invaders. These proteins are part of the innate immune system of the eye, offering a continuous, nonspecific protection against a wide range of pathogens. But the protein repertoire of basal tears is far richer. Consider lipoclin, a protein that binds to lipids and helps to stabilize the outer lipid layer of the tear film, preventing its premature breakdown. This stabilization is crucial for maintaining the integrity of the tear film and minimizing evaporation. Then there are immunoglobulins, particularly secretory IgA, which provide specific immune protection against pathogens that have previously encountered the body. These antibodies act like molecular sentinels, recognizing and neutralizing specific threats, adding another layer of sophisticated defense. The mucin layer, the innermost component of the tear film, is equally critical. Produced by specialized goblet cells in the conjunctiva, this sticky-like layer transforms the hydrophobic surface of the cornea into a hydrophilic one, allowing the aqueous tear film to spread evenly and adhere firmly. Without the mucin layer, tears would simply bead up and roll off the eye, leaving dry spots and compromising vision. This intricate interaction between mucin and the aqueous layer ensures a stable, continuous tear film, essential for clear vision and ocular comfort. In essence, basal tears are a marvel of biological engineering. They are a constant, dynamic system, meticulously balanced to provide lubrication, nourishment, and protection to our eyes. Their complex chemical composition and layered structure underscore the body's remarkable ability to maintain homeostasis and safeguard one of our most vital senses. They are the silent, unseen architects, tirelessly working to ensure that our windows to the world remain clear, healthy, and ready to receive the wonders of light. The psychology of crying, a deeper dive into emotional release, having explored the chemical and biological foundations of tears. Let us now venture into the intricate landscape of the human psyche, where tears serve as a profound and often enigmatic expression of our inner world. The psychology of crying is a rich and complex field, revealing how these seemingly simple physiological responses are deeply intertwined with our emotional well-being, our social interactions, and our very understanding of ourselves. One of the most compelling psychological functions of crying is its role as an emotional release mechanism. In moments of intense emotional arousal, whether positive or negative, our bodies accumulate physiological tension. This tension, if unreleased, can manifest as stress, anxiety, or even physical discomfort. Crying acts as a natural pressure valve, allowing for the discharge of this accumulated emotional energy. This is why, after a good cry, many individuals report feeling a profound sense of relief, a lightness that was previously absent. It's akin to a storm breaking, clearing the air and leaving a sense of calm in its wake. Consider the concept of catharsis, a term often associated with crying. While the idea of emotional purging through crying has been debated, the subjective experience of feeling better after crying is widely reported. This relief is not merely psychological. It has a physiological basis. The act of crying, particularly emotional crying, activates the parasympathetic nervous system, which is responsible for the body's rest and digest functions. This activation helps to slow heart rate, relax muscles, and promote a sense of calm, effectively counteracting the physiological arousal associated with intense emotions. It's a biological reset button, allowing the body to return to a state of equilibrium. Furthermore, the release of certain neurochemicals during crying contributes to this post-cry feeling of well-being. As we discussed, emotional tears contain higher levels of leukenkephalin, a natural opioid peptide. This endogenous painkiller can bind to opioid receptors in the brain, potentially reducing emotional pain and inducing a sense of mild euphoria or comfort. This suggests that crying is not just a passive expression of distress, but an active, self-soothing mechanism, a biological balm for the soul. The body, in its infinite wisdom, provides us with a natural way to alleviate our suffering. The diverse triggers of tears. Beyond sadness, while sadness and grief are perhaps the most commonly associated triggers for tears, the psychological landscape of crying is far more expansive. Tears can flow from a multitude of emotional states, each revealing a different facet of our complex inner lives. Understanding these diverse triggers helps us appreciate the multifaceted role tears play in our emotional regulation and expression. Tears of joy. These are perhaps the most paradoxical, yet profoundly human, tears. They emerge in moments of overwhelming happiness, profound relief, or intense gratitude. Think of the tears shed at a long-awaited reunion, a triumphant achievement, or the sheer beauty of a sunset. These tears often feel different from tears of sadness. They are lighter, often accompanied by a feeling of expansion and warmth. Psychologically, tears of joy may represent an overflow of positive emotion, a moment when the intensity of feeling surpasses our capacity for verbal expression. They can also be a release of accumulated tension, even positive tension, as the body processes a surge of pleasurable neurochemicals. Tears of frustration and anger, while less commonly acknowledged, tears can also be a response to intense frustration, helplessness, or even anger. When faced with a seemingly insurmountable obstacle, a perceived injustice, or a situation where one feels powerless, tears can well up as a release of pent-up energy. These tears may be accompanied by a feeling of heat or pressure and can serve as a signal of extreme emotional distress, indicating that the individual has reached their emotional limit. In some cases, these tears can be a precursor to a more assertive response, a moment of emotional processing before taking action. Tears of empathy, our capacity for empathy, the ability to understand and share the feelings of another, is a cornerstone of human connection. Tears of empathy are shed when we witness the suffering, joy, or profound experience of others. This can be in response to a moving story, a powerful piece of music, or observing someone else's pain or triumph. These tears are a testament to our mirror neuron system, which allows us to vicariously experience the emotions of others, blurring the lines between self and other. They are a powerful affirmation of our shared humanity, fostering compassion and strengthening social bonds. Tears of relief after a period of intense stress, anxiety, or prolonged effort. The sudden release of tears can signify profound relief. This often occurs when a difficult situation resolves, a challenge is overcome, or a period of uncertainty comes to an end. These tears are a physical manifestation of the body letting go of accumulated tension, a signal that the crisis has passed, and it is safe to relax. The feeling of relief that accompanies these tears can be incredibly profound. A deep exhalation after holding one's breath for too long. Understanding the diverse triggers for crying allows us to move beyond simplistic interpretations and appreciate the rich tapestry of human emotion that tears represent. They are not merely a sign of weakness or sadness, but a powerful, multifaceted expression of our inner world, a testament to our capacity for deep feeling, and a vital component of our emotional toolkit. Each tear, regardless of its origin, carries a story, a chemical whisper of the emotional landscape from which it emerged. The biological symphony of crying, a deeper dive into the orchestration, the journey of a tear, from its genesis within the lacrimal gland to its eventual release, is a testament to the exquisite precision of our biological systems. It is a symphony, orchestrated by the brain, conducted by the nervous system, and performed by a chorus of glands and muscles. Let us delve deeper into this biological ballet, unraveling the intricate steps that lead to the shedding of tears. We've touched upon the limbic system's role as the emotional conductor, but the brain's involvement extends far beyond the prefrontal cortex. The seat of higher-order cognitive functions, like decision-making, planning, and emotional regulation, also plays a crucial role. It can modulate the crying response, either inhibiting it in situations where emotional expression is deemed inappropriate, or facilitating it when a release is necessary. This interplay between primitive emotional centers and sophisticated cognitive control highlights the nuanced nature of human crying, distinguishing it from mere reflex. Consider the role of the hypothalamus, a small but mighty region of the brain that acts as the control center for many autonomic functions, including body temperature, hunger, thirst, and, crucially, the release of hormones. When emotional signals from the limbic system reach the hypothalamus, it can trigger a cascade of events. One key pathway involves the activation of the parasympathetic nervous system, specifically the facial nerve, cranial nerve 7, which innervates the lacrimal glands. This nerve carries signals that stimulate the production and secretion of tears, initiating the flow. The neurochemical messengers involved in this process are equally fascinating. Acetylcholine, a primary neurotransmitter of the parasympathetic nervous system, is released at the nerve endings, binding to receptors on the lacrimal gland cells. This binding initiates a series of intracellular events that lead to the increased production and secretion of the aqueous component of tears. It's a rapid and efficient communication system, ensuring that the emotional signal is swiftly translated into a physiological response. Beyond the immediate neural activation, the endocrine system provides a slower, yet equally powerful, layer of regulation. The hypothalamic pituitary adrenal HPA axis, our body's central stress response system, is intimately involved in emotional crying. When we experience stress, the hypothalamus releases corticotropin-releasing hormone, CRH, which signals the pituitary gland to release adrenocorticatric hormone, ACTH. ACTH then travels through the bloodstream to the adrenal glands, stimulating the release of cortisol, the primary stress hormone. The presence of ACHS and other stress-related hormones, like prolactin in emotional tears, suggests that crying may serve as a mechanism for the body to excrete excess stress chemicals, literally shedding the burden of emotional arousal. This hormonal excretion hypothesis, while still under active investigation, offers a compelling explanation for the feeling of relief and calm that often follows a good cry. It suggests that crying is not merely a psychological release, but a physiological detoxification process, helping the body to restore its internal balance after periods of intense emotional stress. It's a remarkable example of how our emotional and physical well-being are inextricably linked, with tears acting as a bridge between the two. Furthermore, the act of crying itself, with its characteristic deep breaths and sighs, can influence our physiological state. These respiratory changes can activate the vagus nerve, a major component of the parasympathetic nervous system, further promoting relaxation and reducing heart rate. This biofeedback loop suggests that the physical act of crying can actively contribute to emotional regulation, creating a virtuous cycle of release and calm. It's a testament to the body's inherent wisdom, its ability to self-regulate and restore equilibrium even in the face of profound emotional upheaval. In essence, the biological symphony of crying is a masterpiece of evolutionary design. It is a complex interplay of neural pathways, hormonal cascades, and physiological responses, all working in concert to help us navigate the intricate landscape of human emotion. From the microscopic dance of neurotransmitters to the macroscopic flow of tears, every element plays a crucial role in this profound and uniquely human experience. The unseen world, microscopic beauty of tears, a deeper exploration. Our journey through the chemistry of tears would be incomplete without a deeper dive into their hidden artistry, a realm invisible to the naked eye, yet profoundly revealing. When a tear, whether of joy or sorrow, finally succumbs to the gentle embrace of evaporation, it leaves behind a breathtaking testament to its origin, a unique, intricate, crystalline landscape These microscopic patterns are not random. They are a direct reflection of the tear's chemical composition, a silent, beautiful fingerprint of the moment it was shed. Imagine a tiny universe unfolding on a glass slide where dissolved salts, proteins, lipids, and other organic molecules, once suspended in a watery embrace, begin to self-assemble as the water recedes. The precise arrangement of these molecules, influenced by their concentrations and the rate of evaporation, dictates the final crystalline structure. This phenomenon, often studied through polarized light microscopy, reveals a stunning diversity of forms: delicate fern-like dendrites, intricate geometric shapes, and swirling organic patterns, each a miniature masterpiece of natural design. Scientists have observed fascinating differences in the crystalline patterns of various tear types. Basal tears, with their relatively stable and consistent composition, tend to form more uniform and symmetrical patterns. Reflex tears, due to their rapid production and flushing action, might exhibit less organized structures. However, it is the emotional tears that often reveal the most complex and visually striking formations. The higher concentration of proteins, hormones, and other organic compounds in emotional tears leads to more intricate and varied crystallization, creating patterns that are often described as unique as snowflakes. Researchers are exploring whether these unique tear patterns could serve as non-invasive biomarkers for various physiological and psychological states. For instance, changes in tear composition, systemic health conditions, or even emotional imbalances. Imagine a future where a simple tear sample could provide a wealth of diagnostic information, offering insights into our health and well-being without the need for more invasive procedures. Beyond medical diagnostics, the study of dried tear patterns offers a unique window into the subtle interplay between our emotions and our physiology. The fact that our emotional state can literally alter the microscopic landscape of our tears is a profound testament to the deep connection between mind and body. It suggests that our tears are not just a passive byproduct of emotion, but an active, dynamic expression of our internal world, leaving behind a tangible, albeit microscopic, record of our experiences. This unseen world of microscopic beauty reminds us that even in the most fleeting and seemingly insignificant aspects of our existence, there lies an extraordinary complexity and artistry. It encourages us to look closer, to appreciate the hidden wonders that surround and inhabit us, and to recognize the profound stories etched in every drop of our salty release. Crying and social bonding, the unspoken language of connection. While the internal catharsis of crying is undeniable, its most profound and perhaps most evolutionarily significant role lies in its capacity to forge and strengthen social bonds. Tears are a primal, unspoken language, a powerful signal that transcends verbal communication and speaks directly to the heart of our shared humanity. From the earliest moments of life, tears serve as a fundamental mechanism for connection, shaping our relationships and fostering a sense of collective well-being. Consider the infant's cry. It is an immediate, urgent signal of need, hunger, discomfort, fear. This cry, devoid of linguistic complexity, bypasses cognitive processing and triggers an almost automatic caregiving response in adults. This innate reaction is crucial for the survival of vulnerable offspring, ensuring that their needs are met. As we grow, the sophistication of this signaling evolves. But the fundamental principle remains. Tears communicate vulnerability and a need for support, eliciting empathy and prosocial behavior from those around us. When an adult cries, they are, in essence, exposing a raw and vulnerable part of themselves. This act of vulnerability, far from being a weakness, can be a powerful catalyst for connection. In a world that often values stoicism and emotional restraint, the willingness to shed tears in front of another is an act of profound trust, a silent invitation for intimacy and understanding. This shared emotional experience can deepen existing relationships and even initiate new ones, creating a bond forged in empathy and mutual support. The neurobiological basis for this empathetic response is rooted in our capacity for mirroring. When we observe someone crying, our brains activate similar neural pathways as if we were experiencing the emotion ourselves. This phenomenon, facilitated by mirror neurons, allows us to vicariously feel and understand the emotional state of another, fostering a sense of shared experience. Level. It's why a powerful scene in a film can bring us to tears, even though the events are fictional. Our brains are wired to resonate with the emotional expressions of others. Furthermore, the chemical signals present in emotional tears, particularly the higher concentrations of hormones and peptides, may play a subtle, unconscious role in influencing the behavior of observers. While research in this area is still nascent, the concept of chemosignaling suggests that these airborne chemical cues could subtly alter the emotional state or physiological responses of those in close proximity. Imagine a silent, invisible language transmitted through the very essence of our tears, subtly influencing the empathetic response of others. This fascinating hypothesis opens up new avenues for understanding the complex interplay between our biology and our social interactions. Across cultures and throughout history, tears have been recognized as a powerful symbol of human connection. From communal mourning rituals to shared moments of joy and celebration, the shedding of tears often marks significant social events, solidifying bonds and reinforcing collective identities. In these shared experiences, tears become a collective language, expressing emotions that words alone cannot convey, fostering a sense of belonging and mutual support. In essence, crying is a profound social act, and our willingness to be vulnerable in the presence of others. It is a silent affirmation of our shared humanity, a powerful reminder that even in our moments of deepest emotional release, we are not alone. Tears, in their salty simplicity, weaving us together in a complex and beautiful dance of emotion and connection, the enduring, spinnery mystery of emotion, a philosophical reflection, have journeyed through the intricate molecular landscapes of tears, explored the sophisticated biological machinery that brings them forth, and delved into the profound psychological and social roles they play in our lives. From the silent, protective basal tears to the cleansing torrent of reflex tears, and the emotionally charged release of emotional tears, each type has revealed its unique story, its chemical whisper of our inner world. Yet, as with all profound scientific inquiries, the deeper we delve, the more we realize the vastness of what remains unknown, the enduring mystery that lies at the heart of human emotion. Why, indeed, do we cry? While science offers compelling explanations for the physiological mechanisms and the adaptive functions of tears, the ultimate why remains elusive, touching upon philosophical questions that have puzzled thinkers for millennia. Is crying merely a biological byproduct, a vestige of our evolutionary past? Or is it something more, a fundamental expression of our consciousness, a unique manifestation of the human spirit grappling with the complexities of existence? Often lead to strength. They are a release of pain, yet they can also accompany the most exquisite joy. This inherent duality suggests that tears are not simply a reaction, but an active process of meaning-making, a way for our bodies to process and integrate the overwhelming richness of our emotional lives. Perhaps tears are a form of embodied wisdom, a non-verbal communication from our deepest selves, signaling not just to others, but to ourselves, the intensity of our experience, of the profound intelligence of our emotional bodies. They are a testament to our capacity for deep empathy, for profound sorrow, and for boundless joy, qualities that define our humanity itself. It reminds us that we are not merely biological machines, but beings capable of immense feeling, of intricate connections, and of a profound inner life. The salty release of emotion, in all its forms, is a constant affirmation of this truth. It is a reminder that our vulnerability is not a weakness, but a gateway to deeper understanding, to greater compassion, and to a more authentic engagement with the world. Sense of wonder for the ordinary. For in the simple act of shedding a tear lies a universe of complexity, a symphony of chemistry, biology, and psychology, and an enduring testament to the beautiful, mysterious, and deeply felt journey of being human. May your tears, whatever their origin, always be a source of release, connection, and profound understanding. The nervous system's intricate dance, a deeper look at neural pathways to truly appreciate the biological symphony of crying. We must delve even deeper into the intricate dance of our nervous system. It is a network of unparalleled complexity, a superhighway of information that connects every part of our body to the command center of our brain. And in the context of tears, this network orchestrates a remarkable interplay of signals, both conscious and unconscious. We've established the pivotal role of the autonomic nervous system, the silent workhorse that regulates our involuntary bodily functions. Within this system, the parasympathetic nervous system is the primary driver of tear production, specifically the facial nerve, cranial nerve 7, a mixed nerve responsible for facial expressions and taste sensation, also carries parasympathetic fibers that innervate the lacrimal glands. When these fibers are stimulated, they release acid, a neurotransmitter that acts like a chemical key, unlocking the tear-producing machinery within the lacrimal gland cells. This leads to a rapid increase in tear secretion, the very essence of a good cry. But the nervous system's involvement doesn't stop there. The trigeminal nerve, cranial nerve, V, responsible for sensation in the face, plays a crucial role in reflex tearing. When an irritant, such as an onion's fumes or a speck of dust, stimulates the cornea or conjunctiva, sensory receptors transmit signals along the trigeminal nerve to the brainstem. This triggers a rapid, protective reflex arc, sending signals back to the lacrimal glands via the facial nerve, initiating the flushing action of reflex tears. It's a lightning-fast defense mechanism, a testament to the body's immediate response to perceived threats. Emotional crying, however, involves a more complex and diffuse neural network. While the parasympathetic system is still the effector, the initiation of emotional tears originates in higher brain centers. The amygdala, as we discussed, processes the emotional salience of a situation, while the prefrontal cortex, with its role in executive functions and emotional regulation, this top-down control highlights the sophisticated integration of emotion, cognition, and physiological response that characterizes human crying system and the brainstem, coordinating the hormonal and autonomic responses associated with crying. It's the master regulator, ensuring that the emotional intensity is appropriately translated into a physiological cascade, including the release of stress hormones and the activation of tear production. This intricate neural orchestration underscores the profound connection between our emotional states and our physical manifestations, revealing tears as a complex output of a highly integrated biological system. The study of these neural pathways is not just academic. It has significant implications for understanding and treating various conditions related to tear production and emotional dysregulation. By mapping the precise neural circuits involved in crying, scientists hope to develop more targeted interventions for conditions like dry eye syndrome, frontier of neuroscience that promises to unlock deeper insights into the very essence of human emotion and its intricate biological underpinnings.